Shake, rattle, and cold, readying the Webb telescope for launch. Presented by Science at NASA. The most sophisticated space science telescope ever constructed, the James Webb Space Telescope, JWST, is targeted to launch in October 2018. With a primary mirror 3 times as wide as the Hubble Space Telescope and a special sensitivity to penetrating infrared radiation, Webb will peer into the far reaches of the universe to reveal how the first stars and galaxies formed after the Big Bang. Stringent testing is underway to prove it can handle an Earth-shaking takeoff and still capture the universe's first light while deeply ensconced in the hyper-cold of space. At NASA's Goddard Space Flight Center in Greenbelt, Maryland, engineers are testing Webb's science payload in special facilities simulating launch vibration and noise. Eric Smith is the JWST Program Director and Program Scientist.
This is the most dynamically complex large telescope ever subjected to vibration tests by NASA. The telescope must deploy in a precisely synchronized sequence as the temperature drops to near absolute zero on its journey to L2. Webb has many interconnected parts of different stiffnesses. All those parts, including the folded, stowed instruments and mirrors, have to survive launch at room temperature. These elements must then all come together seamlessly in the extreme cold to form perfect optical images. All materials change shape as they cool. A flower blossom, a marshmallow, even some metals will shatter or break if hyperfrozen and dropped onto a hard surface or bent. All of Webb's components, once assembled, must cool and move in precisely the right way so that the ultra-fine optical tolerances are met when everything is cold. Think of being able to repeatedly parallel park your car and know the position of your back bumper to within the 1/10 of a diameter of a human hair. That's how accurate we must be in knowing the position of our mirror surfaces.
To make this happen, Webb was vibration tested at Goddard, and it will undergo cryogenic testing at Johnson Space Center in Houston, Texas. Cryogenic testing involves taking the entire telescope and instrument package to a temperature of approximately 40 degrees above absolute zero. That's a very chilly -388 degrees Fahrenheit, -198 degrees Celsius, and making sure its components work as predicted. The science instruments, mirror segments, and mirror-based structure were cold-tested previously. At Johnson, the whole assembly, instrument module plus mirrors, will be cryogenically tested together for the first time. Upon proving it's up to cold snuff, Webb's science section will travel to a Northrop Grumman facility in Redondo Beach, California, for attachment to the spacecraft bus and sunshield. After further vibration and acoustic testing, it's off to French Guiana for a launch atop an Ariane 5 rocket.
Seeing our hopes realized in intricate and awe-inspiring hardware is thrilling. Of course, the ultimate goal of the mission is not the hardware itself, but the knowledge it will return. We're just now beginning to once again reach out to the science research community for their ideas of what to observe with Webb, and that is the most exciting part by far.
For more news about NASA's next great space telescope, stay tuned to science.nasa.gov.